Want to get the most out of your AI libraries simply and easily in Java? Using LangChain4J, all you have to do is to find a Java interface, and it takes care of everything else for you. It's wonderful. It's almost like magic. Welcome to Tales from the Jar Side. I've been playing with LangChain4J for a little while now. Now, in previous videos on this channel, I've talked about how to access a lot of these OpenAI tools and other AI services as though they were RESTful web services. And you can do that. But here they've done all that work for you. They also work with several other services as well, but we're going to take a look at some of their examples that work with OpenAI. Now, this is the home page, such as it is, for LangChain4J. If you've heard the term LangChain before, it's probably because it's a major project in AI in the Python world. The 4J here, obviously, is the port to the Java ecosystem. Now, the way this system works, it does support Java 8 and above, but the examples I'm going to use are beyond that. I'd like to use things like text blocks and records and even collection factory methods that aren't available in Java 8. So here is the home page. Notice the little icon with the, quote, stochastic parrot, as a lot of AI tools are called, with the cup of Java, with the coffee here. And they point out all kinds of features. The one I want to focus on today is this idea of AI services. The idea is to declaratively define relatively complex AI behavior by just defining a method and an interface and having everything happen for you. So let me show you a project. Now, I'm going to build a project of my own, but I'm basing it on an existing one. The existing one is the so-called LangChain4J examples project that has all kinds of sample code in it. Recently, there was a presentation at Devoxx in Belgium, and here's a recording on YouTube in case you're interested, by a woman named Lise Race. I'm not sure I'm pronouncing that correctly, but she did a wonderful job demonstrating how the system is supposed to work, and I highly recommend taking a look at her presentation. I'll put a link in the description of the video. Most of what she used has been incorporated into this example project, and I'm basing most of my examples off of that. I just cleaned it up a little bit to use the more modern Java features. Now, to get started, here is my Gradle build file. So you can use Maven if you prefer. The dependencies are the same. It's just the structure's a little different. So here's the LangChain4J API, if you will, and then you need to pick one of the models that you're planning to work with, a language model. In my case, I'm comfortable with the OpenAI model. I already have accounts for that and everything. But if you prefer things like Google's Vertex or others, they do have implementations of those available as well. But I'm going to use the OpenAI one. I'm not going to get into the embeddings part in this video, but that may be coming in a later one. I do want to enable some logging because we're going to look under the hood a little bit and see how things are actually working. So that's coming later. And I'm using the regular testing stuff with JUnit and AssertJ. That's pretty much everything. So the first thing to look at, of course, is a Hello World program. Here is the Hello LangChain program, which is based on their own homepage and the example they present. What you do is you need to create what's called a chat language model. That's an interface that represents the language model you're using. I am using the OpenAI chat model, and the simplest way to create that is to use this simple method with API key, and that will access your existing API key. The class they use called API keys basically reads the system environment variable that you set up with your API key. So I have that already going. Then once you have the model, you just call generate and pass in a string, pass in your text. And in this case, you get the string answer back and you can print it. Let me run it just to show you what it looks like. And you can see what I got out was, hello, how can I assist you today? Very simple. Now, I'm using a lot of defaults here, and there are the capabilities to change all of those, to pick which model I'm using, to enable logging, lots of stuff you can do, and we'll get to that. So there's the Hello World example. It was 2 lines of code, not counting the print statement. That's pretty much it. Let's see what else we can do. One of the things that LangChain4J provides is something called a prompt template. A prompt template is a string with embedded template variables inside it that you can plug in. And this is pretty natural. This part says, let's make a prompt template from this string. See how they use the double curly braces syntax for the template variables that go inside the template. Then you invoke apply with a Java map. So I'm using the collection factory method of entries on map to make the entries where the text is high and the language is German. And I just want to send that prompt. This test right here just verifies that the prompt worked. When you invoke the text method, you'll get out the actual value, which is say hi in German. Here, I would like to use something from the example project itself that's a bit more elaborate, but it shows you what you can do with this sort of thing. This one says, create a recipe for dish type with the following ingredients. You make the prompt template, you plug in the map, so there's the dish type as an oven dish, and the ingredients are potato, tomato, feta, olive oil. That's all they have. So then you plug in the variables into the template, you call generate on the model using the text and print the response. And this is fairly elaborate. It can take a little while for the AI tool to return a response on that. Here's a sample response I got recently. This recipe for baked potato and tomato with feta cheese. There's the ingredients, there's the list of instructions, and it goes on and on. I can't assert that I'll get that every time because I could get any dish, and I tend to get different dishes each time. But look how nice that is. Now, this is all great, but wait till you see AI services. This is where life really gets interesting. Here's how easy it is to make one of these so-called AI services. All you do is make an interface, and this is their sample, an assistant interface. You put in a method, here I'm calling it chat like they did. The chat takes a user message as opposed to a system message. That's a distinction you could make in OpenAI. And you're returning a string. And guess what? I'm basically done. I'm basically finished. To see it in action, let me do a test here where I can show that we call the create method on the AI services class. Now, the AI services class says this is a simpler and more flexible alternative to chains. You define your own API, a Java interface with one or more methods, and AI services will provide an implementation for it, which they call an AI service. This is really awesome. This simple string in and string out is nice, but you could return a wide variety of return types, and we're going to see that. So I'm going to use, again, the simple OpenAI chat model and plug into the create method. That will return an implementation of assistant, and all I do is call chat, and let me run that, and you'll see what happens. And it worked. All I got back was, hello, how can I assist you today? So it doesn't look like much yet, but all I did was define one interface and then create the service and use it. Let's see if we can do a little bit more. This is another sample service they suggested called Translator. Once again, I only have one method, but this time I have two separate template variables, and one's going to be handled inside a system message. That's kind of a global message to the AI, to the large language model, to tell it to keep this in mind, setting context as it were. And then one is a user message that we're actually going to execute that might be different on every request. So the system message is, you are a professional translator into, and there's your language. And the user messages translate the following text. They use an annotation called @v. @v here specifies the values of method parameters together with prompt templates defined by user message and system message. So here you see that the text is going in at this spot and the language is going in at this spot. And once again, all we really have is an interface with a method in it, and the rest is just some annotations. Let's see how to use it. On this translator test, I'm going to use the builder, set a timeout here, and this is the mechanism. Now below, just to let you know, I could do using a prompt template the same way I just demonstrated earlier. Say text in language. Here's where I do the apply on the prompt template to get the prompt, plug in the map where the text is hello, how are you? The language is Italian. Go ahead and generate from the model and print it. And in fact, let me run this one just to show you what it looks like. And you see it return, ciao, come stai? But look how simple this is with the AI service. All I do is create the translator using my OpenAI chat model, and I just call translate, and these values get plugged into the system message and the user message, and then the method gets invoked and it's already implemented, and I just get back the result directly. Let me run that one. Again, nice and simple. I didn't print out the result, but I did test it, and the result is exactly the same. So there are ways to get values into it. Now let's move on to different return types. So far, all I've been returning is strings. And, if I can't return a string, I might as well give it up. So let's look at something a little bit more elaborate. This one is called a sentiment analyzer. Again, this is taken from their sample project. They defined a Java enum, positive, neutral, and negative values for sentiment. There's my enum. The sentiment analyzer, again, is an interface, and this time we'll have two methods in there. One that takes a user message that says, analyze the sentiment of it. If you have a template variable and you don't give it a name, then the word it is used, and that only works if you only have a single template variable. But then that'll get plugged in here as the text. But look at the return type now. This time the return type is the enum. I want one of those sentiment values. However, here they also said, does it have a positive sentiment? So again, we put in a string, and this time we're going to get back a Boolean. Well, that's interesting. So it's going to have to figure out whether it's positive, negative, or neutral. Let me go to the test. The test says, sure, let's create a sentiment analyzer with that API key. And now again, all I do is invoke it. Analyze the sentiment of, I love Java. It's a pretty strong statement, but hey, it's positive anyway. And that should be equal to the positive one. And then I could just say, is that positive, and see if it's true. And let me run both of those tests. Now in this case, something interesting happened. You see that I actually got an interrupted IO exception. This system is nicely robust. What it does is it builds in the opportunity to try this 3 times before it actually fails. So even though something happened with the network or the server side, I don't have to worry about it. I just retried it and it worked. Now, unfortunately, all I see in the output here is the exception, but you see the test did pass. I just didn't happen to print anything directly on that. I did, in fact, get back the proper thing. And on the E is positive, that one worked directly. So I didn't have to wait for that one. So again, a little bit of misleading, hey, wait a minute, we have a problem, when in reality, it just went, yeah, something went wrong this time. Yeah, I reran it. And it's fine. And it worked great. And not only did it check the enum, it also checked the Boolean as well. Now, this is all being done by JSON parsing, but we'll get to that. So let's move on to another mechanism. Another example. This one is a DateTimeExtractor. This one has methods extract date from, extract time from, and extract date time from. It's going to take the text here and try to figure out the date or the time or the date time in terms of local date, local time, and local date time from the java.time package. We're providing the user message, extract date, extract time, etc., and letting it figure it out. So let's take a look at the test. The test, once again, will just create the AI service. The text here says, the tranquility pervaded the evening of 1968, just 15 minutes shy of midnight, following the celebrations of Independence Day. So you can see there's a date and a time in there. There's Independence Day, which presumably is in the US. They're talking about a year explicitly. And then this phrase, which indicates the time of day, 15 minutes shy of midnight. Here, they're going to use the same text in all 3 methods and extract the values out of it. And once again, I'm not actually going to print them, but let me run them all. And once again, all 3 tests passed without an issue. It actually managed to extract July 4th, 1968 at 23:45, at 15 minutes before midnight for the date time, and the others are just pieces of that. But I ran them all independently and they all worked. Nice. But here's my favorite. Here's the one that convinced me that I really want to use this in the future for everything. What I have here is a person extractor. Now, person, I'll show you in a moment, is just a Java record. The example they use, of course, is a POJO, but I'll just use a record here. So the user message says, extract information about a person from the supplied string. So that'll be the argument. And I'm getting back a person, and a person is a record with first name, last name, and birth date as a local date. So 2 strings and a local date. Let's take a look at the test. So the test says, all right, let's create a builder and set the key. And then we're going to create the service using that model. Now, I could run this as is, but this time I'm using a builder for the model because I want to see the requests. So I put in log requests is true and log responses is true. And that's why I added in SLF4J's library and logback. And in addition, in case you're interested, I also put in a logback.xml configuration file that just sends message to the console appender. I'm not trying to put this in a file or anything. I just want the output shown here. That combination, the XML file, the dependencies, and setting these log requests and log response methods to true is what's going to give me some logging output. Now let's look at the text. The text says, in 1968, amidst the fading echoes of Independence Day, a child named John arrived under the calm evening sky. This newborn bearing the surname Doe marked the start of a new journey. I don't know where they got this text, but okay, there it is. So you can see there is a first name in there. There's a last name in there, and there's something to mark the local date, the birth date. But we're asking the LLM, the language model, to parse that and figure it out. All we have to do is call extract person from, and we should get a person back and check all of this. But this time I've enabled logging. So let's see what we get now. Okay, let's look at the output. So as expected, the framework sent a post request to the OpenAI API's completions endpoint. There's the headers with the authorization that presumably is a part of my API key. The body has a model. The default model is GPT 3.5 Turbo. I could change that. That's another property I could have put on the builder. The messages in the role of user was content, extract information about a person, blah, blah, blah. But here's where it gets interesting. Let me get to the end of that part. This newborn bearing the surname Joe, etc. Here we go. Bearing the surname Doe marked the start of a new journey, period. How about this? Then what they added was, you must answer strictly in the following JSON format. Braces, first name of type string, last name of type string, birth date of type date string, which is the ISO 8601 formatted date time, and temperature of 0.7. What did that do? I'm assuming what happened is they took the record, the person record, and serialized it to JSON, and then used that to define the string that they appended to our request to say, here's what I want the output like. So now if you look at the response, we got back a 200, which is fine. And there's a bunch of headers saying, yes, we got JSON data back, etc. And in the body, when you go down under the chat completion, under choices, index 0, message, content, there it is. There's your first name, John, last name, Doe, birth date, and there is the birth date in ISO 8601 standard format, 1968-07-04. And there's my prompt tokens and everything to find out what it cost me to do that, which was not bad at all. And it worked like a charm. Isn't that amazing? I mean, to me, that was basically almost magic. So I did do some digging under the hood and looked in and found that the JSON parser they're using is Google's Gson. And they actually have a class called JSON. I think I can bring that up. In their JSON class, inside of the OpenAI API, or their API inside here, they have a Gson builder which uses lowercase with underscores, which I did in my other videos, and registered some type adapters, and they have to JSON and from JSON, and all of that's working. And if you dig into the LangChain API, you can see how they use that in order to append that message and then deserialize the output. And there you have it. I mean, how nice is that? It's amazing what you can do with a simple Java interface and just sending messages, user and system messages back and forth with templates. Now, there's tons more this thing can do. It can do embeddings. It can do, well, lots of neat features. But we'll save that for future videos. Hopefully you enjoyed this part. Please enjoy the rest of the videos in the playlist. And please feel free to subscribe so you will see other videos that show you how to work with these other features in LangChain4J. Thanks for watching.
Hey there, devs, it's time to tune in. Tales from the dark side, let's begin. Java, Kotlin, and Spring, oh my. Groovy, Gradle, don't be shy. Tales from the dark side, oh yeah. Crack open the code, let's take a ride. From design patterns to the latest trends, your weekly tech dose that never ends.